So we have been given I of n equals to 0 to pi sine square nx over sine square x dx, where n is a natural number and we need to find out the right options. So this problem falls under reduction formula problems. So we write in plus 1 equals to 0 to pi sine square n plus 1x by sine square x. So here I have taken started with n plus 1. So we write this down as 0 to pi. Then I have expanded sine of n plus 1x as sine nx times cos x plus cos nx times sine x, and the whole thing divided by sine x and the whole square of this. So if we simplify this, then we would have in plus 1 equals to integral 0 to pi sine square nx times cos x cos square x over sine square x, plus then next we'll have integral 0 to pi and then 2 sine nx times cos nx times cos x times sine x over sine square x. So one sine x will get cancelled, so we'll be just left with 2 sine x cos nx times cos x over sine x plus integral 0 to pi cos square nx over sine square x times sine square x, so they'll get cancelled out, so we just have 0 to pi cos square nx dx. So now you'll observe that in the first integral, if we write cos square x as 1 minus sine square x, so we will have sine square x times 1 minus sine square x over sine square x plus 2 times, now we can write down 2 sine nx into cos nx as sine 2nx sine 4nx over sine x plus integral 0 to pi cos square nx dx. So the first integral sine will now become 0 to pi sine square nx over sine square x, and then when sine square x will get cancelled, so we'll have minus integral 0 to pi sine square nx dx, because sine square x terms will get cancelled out, and then to this we combine 0 to pi cos square nx dx and then plus 0 to pi sine 2nx times cos x over sine x dx. So you will observe from here that the middle two integrals, which are like sine square nx and cos square nx, so we can combine them to get cos 2 cos square nx minus sine square nx dx plus 0 to pi sine 2nx times cos x over sine x dx. So you will see the first integral has now become simply in. So 0 to pi sine square nx by sine square x. Now let me denote the last integral by some different symbol u of n. So now if we clear whatever we have written, so we can conclude that I of n plus 1 is in plus 0 to pi cos 2nx dx plus un. Now let me just integrate 0 to pi cos 2nx. So we will have in plus 1 equals to in plus sine 2nx over 2n, and then we put the limits from 0 to pi plus un. Now as you can see, if you put x as pi and 0, so sine 2nx by 2n, so that complete thing will become 0. So we are left with in plus 1 is in plus un. Now let us start off with the un, which is integral 0 to pi sine 2nx times cos x over sine x dx. So here if you observe that if we take un plus 2 minus of un, so this will become integral 0 to pi sine 2n plus 2 times of x minus sine 2nx over sine x and times cos x. So now we'll apply the difference formula over sine 2n plus 2x minus sine 2nx. So it will give me 2 cos 2n plus 1 times of x times sine x cos x over sine x. So this sine x and this sine x, they will get cancelled out. So numerator denominator. So we are just left with now un plus 2 equals to un plus 2 minus un equals to integral 0 to pi, and then we can combine 2 cos 2n plus 1x and cos x, and then we can apply the addition formula for cosine. So this will give me cos 2n plus 2x plus cos 2x, cos 2nx. And then if we integrate this, so this will simply become from 0 to pi sine 2n plus 2x over 2n plus 2 plus sine 2nx over 2n, and then we'll put the limits from 0 to pi. So we'll find that both the values, like if you put both the limits, the final thing becomes 0. So from here we conclude that un plus 2 minus un is equal to 0. So we can conclude that un plus 2 is equal to un. But depending on the value of n, we can have two kind of series. So let us first calculate u1. So if we calculate u1, so we'll say 0 to pi sine 2x times cos x by sine x dx. Then we expand sine 2x, and this gives me 2 sine x times cos x over sine x dx. So this will finally become sine x times cos square x over sine x. Sine x gets cancelled, and we are left with 0 to pi integral 2 cos square x, where I can use a double angle formula, and we get 1 plus cos 2x. So this, if we integrate, we get x plus sine 2x over 2, and then we put the limits from 0 to pi. So my final answer will be pi. So we conclude that u1 is equal to pi. Similarly, we can calculate u2 also. So we write 0 to pi sine 4x times cos x over sine x dx. So again we break sine 4x as 2 sine 2x times cos 2x and times cos x over sine x, and then we further break sine 2x as 2 sine x into cos x. So the idea is to get rid of the sine x in the denominator. So this will eventually give me 4 times 0 to pi cos x times cos 2x. So that becomes cos square x times cos 2x. Sin x will get cancelled. Then again what I'll do is I'll take 2 from this 4 and write u2 as 2 times integral 0 to pi 2 cos square x, and then 2 cos square x can be further written down as 1 plus cos 2x. So if we write all of that, we'll finally get u2 is equal to 2 times integral 0 to pi times 1 plus cos 2x times cos 2x. So again, if we multiply by this cos 2x thing, so if we simplify the integral, so this will give me 2 times integral 0 to pi cos 2x plus cos square 2x. Then again, we can focus on cos square 2x and borrow that 2 which is lying outside. So eventually this will become u2 is equal to 2 times 0 to pi cos 2x plus 2 times cos square 2x dx, which can be written down as 1 plus cos 4x. So let us first integrate this 0 to pi cos 2x, so that becomes 2 sine 2x by 2 and 0 to pi, and the second term it will become 1 plus cos 4x dx, and the limit will be from 0 to pi. So if we integrate the last integral, this integral 1 plus cos 4x, so this will give me x plus sine 4x by 4 and the limit from 0 to pi. So if we do all the substitutions of the limits, so my final answer will be that u2 is simply equals to pi. So we have got u1 equals to u3 equals to u5, so on and so forth, equals to pi, because un plus 2 is un. So if u1 is pi, u3 is also pi, u5 is also pi. Similarly, u2 is also pi, so u4 is also pi, u6 is also pi. So in general, we can say that u of n is equal to u of n plus 1. So now let us get back to our initial integral, where we had in plus 1 equals to in plus un. So now un can be replaced by its value of pi, so we get in plus 1 is equal to in plus pi. Now let us calculate I1. So I1 is simply 0 to pi sine square x over sine square x dx. So we find that I1 has the value of pi. So from here now we can conclude that I2 is equal to pi plus pi, which is 2 pi. Similarly, we have I3 equals to I2 plus pi, which equals to 3 pi. etc. So we can conclude that I of n is now equals to n pi, and looking by this options, we can say in plus 2 plus in is equal to 2 times of in plus 1. Hence we get options A and option C as my right answer.